Okay, class. In this video, we're going to be finding zeros. We're going to be looking at difference of squares polynomials, and then we're going to look at sums of squares polynomials. First, let's remind ourselves, what is a zero of a polynomial? A zero of a polynomial is an x value, that's some number that x equals, when y is equal to 0. In other words, when my y equals 0, what does x equal? Whatever x can equal when y equals 0, that number is called a zero of my polynomial. So let's look at trying to find the zeros of a difference of squares polynomial. We're going to look at this polynomial for starters. Y is equal to 4x squared minus 25. Now, why am I calling this a difference of squares polynomial? The reason is, it is in this form. Difference of squares polynomials have the form a square number, okay, right here this is a squared, right? A can be anything. It's a square number minus b squared. Or put it another way, a difference, because in math subtraction is called difference, of two square numbers. It's a difference of squares. Now, we learned last quarter that you can factor difference of squares polynomials by simply writing them in this form. In one parenthesis, you have a minus b, and in the other parentheses, you have a plus b. All you have to do is figure out what's the number that's being squared in both terms, and then you can just fill out this formula. So let's look at this polynomial here. Let's look at our example. The first thing we have to do is set y equal to 0. Because to find the zeros of a polynomial, we have to make y 0 and figure out what are our x values. The second thing we want to do is factor. So, just like in this formula, I need to figure out what number is being squared in my first term, and what number is being squared in my second term. Well, I can pretty easily see that 2x is the number that would have to be squared to make 4x squared in my first term. In the same way, 5 is the number that would have to be squared in my second term to make 25. Now that I've figured out my a and my b, I can just plug those into the formula. In my first parentheses, I've got a minus b, so that's 2x minus 5. And in the second parentheses, I've got a plus b, that's 2x plus 5. So there are my factors. Now, once I've found my factors, I can solve this equation independently. Because when you have the factors of a polynomial, since the factors are multiplied together, and since the answer needs to be 0, what you have to do is just make either factor equal to 0 and solve for x, and that would make the equation true. So I'm going to set my first factor, 2x minus 5, equal to 0. And I'm going to set my second factor, 2x plus 5, equal to 0. And I'm just going to solve for x on both sides. So on this side, 5 is going to equal 2x when I add 5 to both sides. And x is going to equal to 5 over 2 when I divide by 2. In this equation, negative 5 is going to equal 2x when I subtract 5 from both sides, and x is going to equal to negative 5 halves when I divide both sides by 2. So the zeros of this polynomial are working out to be 5 halves and negative 5 halves. So there's my answer. All I had to do was factor, and then set each factor equal to 0, and then solve for x. And I found my x values that make y equal to 0. Let's look at sums of squares polynomials. The first example we're going to look at is y equals 9x squared plus 81. So, why am I calling this a sums of squares polynomial? Well, it's because it's in a very similar form to my last polynomial. I can write it as two square numbers. The first square number would be 3 times x, because if I squared 3 times x, that would give me 9x squared. And the second number would be 9 squared, because if I square 9, that would give me 81. The only difference is that this is not a difference of squares. This is not one square number minus another square number. This polynomial is a sum of squares. Now what we all learned last quarter was that sums of squares polynomials cannot be factored. These are non-factorable. Or another way to put that is to call them prime. Prime means non-factorable. So if we can't factor, how are we supposed to find the zeros of this polynomial? Well, the answer is that you can't, because there are no zeros, no real zeros anyway. So when we see a sum of squares polynomials and we're asked to find the zeros, what we need to say is that there are no real zeros. And that's my answer. If you're asked to find the zeros of a sums of squares polynomial, simply point out that it is a sum of squares polynomial as a way to justify the answer, which is that there are no real zeros. What do I mean, real zeros? Why do I have to specify that there are no real zeros? Well, imagine that if I was a creative person and I tried to solve this problem in a slightly different way than you're usually supposed to. So I decided to try it to solve this problem without factoring. Well, I need to set y equal to 0. And then what if I just tried to solve for x without factoring? I could subtract 81 on both sides. I could divide by 9. And I could take the square root of both sides. If I did all that, you can see my answer would be x is equal to the square root of negative 9. Well, what did we learn last year about the square root of negative numbers? The square root of negative numbers are imaginary numbers. So the square root of negative 9 is an imaginary number. In other words, it's not a real number. So even if you were to try to say that the square root of negative 9 is a 0 of this polynomial, it's not a real 0. It's an imaginary one. So when we're asked to find the zeros of a sum of squares polynomials, that's why we say there are no real zeros. Because you might say there's imaginary zeros, but we don't want to get into that. So we're going to say there are no real zeros because we can't factor. It's non-factorable.